Okay, a carbanion is a species that contains a negatively charged trivalent carbon. What is the electronic relationship between a carbanion and a trivalent nitrogen, such as NH3? How many valence electrons does the negatively charged carbon atom have? What hybridization do you expect this carbon to have? And what geometry is the carbanion likely to have? So let's look at these one at a time. So what's the electronic relationship between a carbanion and a trivalent nitrogen compound such as NH3? So we have a carbanion here, which has 3 hydrogens. So this is a methyl anion versus nitrogen, which has a lone pair and 3 hydrogens. Well, if you count the number of lone pairs, they each have one lone pair. So there's one lone pair in each of these. And there are 3 single bonds in each. And so if you think about the concept of steric number, when you're talking about how many things are attached, you count both atoms and lone pairs. So there are actually 4 things attached. The steric number is 4. And same here for ammonia, NH3. So the steric number is 4 for NH3. And so these two are what you would call isoelectronic. They're isoelectronic, and they really should have the same hybridization and the same shape. So if the steric number is 4, that means that this molecule is sp3 hybridized, and the same with ammonia, right? And if something is sp3 hybridized, it has to be tetrahedral. And the same with ammonia. And so what does that look like? Well, that means that if we have a carbon atom with a lone pair, the lone pair is in its orbital here, and you can think of that as being sort of the pole here, and that would mean that one of these hydrogens is sticking out. We'll have, let's say, another hydrogen going back and another hydrogen in the plane of the board. So this is kind of, if it's a tetrahedral geometry, one of the kind of corners and vertices of the tetrahedron is this lone pair. And so you have these, this tetrahedral geometry here like that. And it's kind of hard for me to draw a straight line, but you get the idea of a tetrahedron. And you'll see a lot more tetrahedra before the quarter's over. Nitrogen in ammonia, it's the same thing. It's got this sort of pyramidal shape. And sometimes people like to think of nitrogen as just, if you kind of ignore the lone pair, you're still going to see the hydrogen atoms in this sort of tripod arrangement. And the reason is that these electrons in these sigma bonds are trying to get away from this lone pair, and the best way to do that is to have this kind of pyramidal shape. It's definitely not a trigonal planar shape, because this is the best way to get electrons in these orbitals away from the lone pair here. So the carbanion is likely to be tetrahedral.